I'm going to talk to you about how to build a production quality project in Python. A little bit about myself. I'm an on-metal developer at Rackspace. I went to Texas A&M way back in 2006. Whoop. Howdy, everyone. And there's my email, and I'm Cliff_H on Freenode. I hang out in several OpenStack channels, so ping me there if you want to get in touch. So about this talk, there are a lot of great tools available for use with Python projects, which make creating and running a production quality service much simpler. And these are tools that you can get started with real easy and very quickly. I built a service that works with OpenStack and on-metal, and going through that experience really helped me learn a lot about the different things that are available for Python for making great projects, and I want to try and share the stuff that I learned with you all. And I'll try and give small examples of each tool as I go. So what's on-metal? Well, on-metal is basically the cloud plus a lot of extra speed. So typically when you request a instance from the cloud, you're getting a virtual machine. But with on-metal, you're actually getting a full-blown bare metal machine, which means you have full access to the machine. And you can provision these machines within minutes. One such use case for on-metal is I have a ton of extra load on my website, and I need to handle that load very quickly. And you can do that very easily by spinning up a new on-metal instance and getting way more power and bang for your buck than you would out of a VM. Bare metal also avoids the so-called noisy neighbor problem, if any of you are familiar with that, in VMs. When you share machines with other people or other virtual machines, you're going to run into issues sometimes when some are not being very nice and they take up a lot of resources off the machine, and then it will kind of reduce the quality of life for your application. And you can avoid that completely with having a dedicated machine to your own application. So the service that I built is called Arsenal. It's written completely in Python. It works with OpenStack, and you can kind of see here on the diagram. Who all here is familiar with OpenStack? Anyone? Okay, a few people, a lot of people. It talks with Glance, Ironic, and Nova, and it gathers different information from these services, and then collates that information and then makes decisions about how to cache operating systems onto bare metal nodes. And you might ask yourself, well, why would I want to do that? The answer being, you can provision the nodes a lot more quickly if the operating system is already on the machine. And you can see an example of a cache right there in real life. So to talk a little bit about how it does it, it will go to Glance and download the operating system to the machine before a customer actually gets it. And when a customer actually requests a machine, the Nova scheduler will see, oh, this machine has an operating system image cached, and then it will provision that machine for the customer, and they'll get their node a lot faster. So Arsenal's working in production today. It's actually doing pretty well. As you can see, uncached provision times are on the order of about 7 minutes. But if you hit a cached node, it's more than half the time from the time that a customer requests an instance to the time that the customer can SSH into the instance. So there's a pretty dramatic improvement. So this is just to illustrate that, yes, I've built something that actually works. And a short disclaimer here, the tools and stuff that I'm going to recommend are my opinions. It may not work for your particular instance or project, but I hope that I introduce some tools that help some of you out. So, the road to production. And just pretend that I had the time to Photoshop that picture to say production. So this is a pretty good quote about how easy it is to screw up with computers. It's really damn easy to screw up very quickly considering how fast they run. So a good place to start with your project is Python, obviously. I think we're all here because at the very least we're interested in Python. Python does a lot of things that help us create projects quickly and easily. The syntax is very clean. It's easy to write. It's easy to, with clean syntax, it's easier to make fewer mistakes and catch mistakes sooner. And thankfully, there's a lot of tools that accompany Python that can make your life easier. But you all know this, and that's why you're here, right? So let's talk a little bit about project design before getting into particular tools. A few good things to keep in mind is you should have a clear goal when you create your project. It should try to accomplish something tangible and straightforward. You should try to separate your concerns when you're writing your code. It's very good to segment your code as much as possible so that each segment does one thing and one thing well. It makes it a lot easier to test your code, and I'm going to be talking about that a lot. It's also good to be lazy. You should try and do as little as you possibly can. And by that I mean try to write as little code as you can. Python has lots of libraries available that can do tons of things that have already been done. They're probably tested. They work pretty well. Go out and use them. Also, one tip, who's heard of don't repeat yourself? Okay, some of you. Basically it means write code once and reuse it everywhere. Don't ever copy and paste your code. You'll end up regretting it in the future. So here's a slide that kind of outlines Arsenal's design, although I'm not sure how easy it is to see on this screen. But basically, I've separated the concerns of the service so that you have the strategy on one side, which is dealing with internal decision making, and you have what I call the scout on the other side, which tries to deal with just the outside world, collect information, and then it passes this information back and forth through the director scheduler, which is the main service that runs. So you decided to create a project. You should pick a name for it. You should try to avoid namespace collisions with other projects. A good way to do that is to Google the name that you're trying to pick. Also, you should check out PyPy, the Python package index, because someone might have already taken your name. Actually, when I put Arsenal into the package index, I found out that someone had already taken the Arsenal name, so I had to pick a different name to put in there.
Probably a soccer fan.
Maybe. So when you start writing your project, you definitely want to save your project, or save your progress. This may be something that a lot of people are aware of, but definitely use source control with your project. You don't want to be in the situation where you've written a bunch of code and then your hard drive crashes and you've got nothing to show for the hundreds of hours you spent writing it. I like Git a lot. I bet some of you are aware of it. It works really well with GitHub. Has anyone ever here worked on a project that didn't have source control? Okay, a couple of you. You know what I'm talking about.
Think about it.
I know, neither do I. I've been there. It's not fun. And a good tool to use to create the skeleton of your project is called Cookie Cutter. It's really easy to use. All you have to do is call it from the command line in your project directory, and you can feed it a repository that it creates the skeleton from. For Arsenal's case, I use the OpenStack Cookie Cutter skeleton because it provides a lot of different tools kind of out of the box. One of the cool things that it includes is test repository. Test repository makes it really easy to run and rerun unit tests. Something that I am going to hammer on repeatedly. And I'll try and provide these slides later on so you don't have to copy everything down. So you've got a skeleton of your project going, but you probably don't want to do everything yourself. You should spend some time and look for Python libraries, and Python comes with a really nice utility called pip, which will let you download and install modules directly from PyPy. As you can see here, I've installed the nuclear module, and I'm using it to React. Pretty simple. And a word about choosing libraries for your project. I would definitely favor libraries that are already included in the Python installs itself. For instance, there's the unit test module that's included with Python. It works pretty well, and you know it'll be included in every Python install. A few decent metrics that I found for selecting libraries is look at how much is downloaded from PyPI. Go to the project website and make sure that there's documentation available. Is it well documented? Does it look like the documentation is complete? Make sure the library looks like it's easy to use and actively developed. Also, make sure that it's nice if the project has automated unit testing, because that means that you know that when they're updating the project, they're not breaking things that they developed in the past. And here I have an example of a requirements file. Requirements file lets pip know what libraries your project needs to install in order to function. you definitely want a requirements file for your project, and you probably also want a test requirements file, so that, because you're going to have some libraries that you probably test with that don't need to be installed alongside the main application. So here you can see the requirements file for Arsenal, and as you can see, I've pinned every module version precisely. For me, I found this to be reducing the amount of fear I had when going to production with Arsenal. There are circumstances where you may not want to pin your version exactly. It may be okay to automatically pull in new versions of the library, especially if there's any security vulnerabilities found in it, things like that. But I would definitely recommend trying to stick with pinning as much as you can. And I've been told by my colleagues that this is a somewhat controversial opinion. I mean, how many of you pin your requirements exactly? One guy, a little bit. Right, yeah. So the requirements file supports sort of a, you could do a greater than or equals, and then it would always pull in a greater version. You can also kind of clamp it to a particular range of versions if you want to. And you can go check out the pip documentation to learn more about how to use requirement files. So, one of the biggest things that you can do to make your project production ready is to write tests. Here you can see Picard on the left. He's having a great time because he wrote tests for his project. They're passing all the time, so whenever he makes a change and makes all the tests pass, he's really happy. And then on the right here you have poor old science dog who has no idea what's going on with his project, because every time he makes a change, the only way he knows that he hasn't broken anything throughout the project is to go back and manually test things. And that's a horrible place to be in. Just a quick poll, how many people write unit tests for their projects? Okay, all right. How many people don't write unit tests for their projects? Why aren't you writing unit tests for your projects? So I just wanted to show a quick example here of how easy it is to write a unit test in Python. Python has a built-in module called unit test, which you just import and then subclass the unittest.testCase class, and then you write your test functions, and they can do something really simple like call a function on a module you wrote, and then you can write a quick test, assert things are happening the way you expect them to happen. And here's an example of an Arsenal unit test. It's not doing anything too crazy, but you can see that it's asserting that what I'm getting back from this function find image differences expects, does what I expect it to. In a way, you can think of tests kind of as mini proofs of your program. Another great unit testing tool is mock. Mock allows you to write unit tests that truly have no side effects. Is anyone here familiar with mock? Okay, some people. Mock is really great and really easy to use. It's included in Python 3 now, I think, as a standard library module, although in Python 2 you've got to get it somewhere else. PyPy, use pip. And here's an example of a use of mock. You've got a function decorator here, which basically says, patch this particular object in this module, and then it will pass the mocked object into the function. And then here I'm turning on the log statistics configuration object in my, or option in my service, and then I'm making sure that when I'm issuing the directives, it's actually calling the log function as expected. So, I mean, this is kind of a simple example. I just don't want to output logs in this situation, but you can use mock to basically patch out other things like, say, calling to a database or calling to an HTTP service. When you're unit testing your project, you probably don't want to actually reach out to the outside world. So it's really great for making it easy to unit test things that have side effects. So a few points about writing tests. Basically write it for everything that you can. If you have any uncertainty about the code in your project, you should be writing a unit test to cover it. Now, I'm not saying that your unit tests are going to be perfect or catch everything. The tests are only going to be as good as you write them, but the effort that you put into writing tests as you're writing code will pay dividends by, I don't know, 100 times. Because every time in the future that you make changes to your project, you can go back and run these tests and still have some confidence that your program is still running the way you expect it to. When you're writing tests, you should probably do your best to keep an eye out for edge cases, failure scenarios. It's okay to have failure situations for your program as long as you understand how it's going to handle those scenarios. And unit testing is a great way to make sure you understand that your program can handle those situations gracefully. And again, I want to stress that every test you write today is probably going to be around for the life of your project, and it will always be there helping you avoid bugs getting into production. You might have to go back and rewrite tests now and then, but that's a small price to pay to have confidence when going to production. Okay, so you've got a set of unit tests, but you need to run them whenever you're making changes to your project or there's no point. Tox is a great little program that allows you to build a test environment using Python's virtual env program. And so it makes it easy to write test once and then create environments for different versions of Python, like Python 2.7 versus some version of 3. I think 3.5 just came out. So it'd be really easy to get your unit tests and make sure that they run under 3.5 with Tox. You can also do things like test the source code for compliance with things like PEP 8, which is the basic style guidelines for Python. And here's an example Tox INI file that you can use with Tox. It's kind of hard to see, but if you look at the env list up there, you've got Py 2.7 and Flake 8, I think. Oh no, PEP 8. But it kind of tells Tox how to install your project using the requirements files, and then how to run the tests on your Python project. And so if I just wanted to also see if my project would pass under Python, say 3.5, I would just add Py 3.5 to that env list at the top, and I could start making sure that my project is compliant. So now you can run tests every time that you make a change. And that sort of leads to continuous integration. And a really cool tool that you can use to enforce this continuous integration is Travis CI. And it's actually very easy to use with GitHub. Every time you create a pull request or you receive a pull request for your project, you can set up Travis to automatically run tests against that pull request, and that will give you some confidence that this new code coming in your project is not going to break the world. And here's an example Travis YAML file you can include with your project, which is pretty simple. It just tells Travis how to run your tests. It needs to install talks in this example, then call talks against the different environments you want to run against. In this case, it's Py27 and Pep8. And you can do this by enabling webhooks through your Travis CI profile page. And it's free for open source projects, so there's no reason not to use it. Another great tool to use for your project is code review. I think this illustrates all the fear we have when other people review our code, but typically you should view it as a positive experience. There's a lot of things to learn from other people's perspective on your code. I've definitely had people catch mistakes that I've made in almost every review I've put up. So it's definitely great at catching, bugs before they can make it to production. So again, GitHub does a really good job of integrating code reviews with pull requests. So it's something I would definitely recommend using on your project. So you're building your project, but how is anyone else going to figure out how to use your project if you don't write documentation for it? There are a couple of great tools that you can use with Python, Sphinx being one of them. You can write your documentation basically in a plain text format, something like restructured text. And Sphinx will automatically build that text into a nice looking documentation format like HTML or PDFs. There you can see the command line that I use to build the documents for Arsenal. And so once you have documents, you can also get them online really easily with readthedocs.org. I highly recommend it. It works well with Sphinx. And you can also enable a webhook with your GitHub project so that whenever you push changes to your project, it will automatically pull the documentation, rebuild it, and post it online. So you know your documentation is always up to date as long as you're updating your documentation as you update your project. And you can find Arsenal's documentation online at readthedocs.org if you want to use it. So you've got a project, you've got documentation, but you're going to find issues with it invariably. You should always document what's going on with your project somewhere. Again, GitHub has a decent issue tracker that you can use to file bugs. And then it's pretty neat that if you you can reference issue numbers in your GitHub commit, and it will automatically update those issues, even close them if you want, just based off the commit message once it's merged into the master branch of your project. And you also want to get your project out there to available to other people. So you should publish your project at the Python package index. It's pretty easy. You just got to create an account on PyPI, and then you can upload your project. And after you've uploaded your project, people can just install it easily from the command line and use it. In this case, pip install arsenal director will install Arsenal on any Python enabled machine, which is pretty neat. So your project's alive. It's ready to run in production, right? You've got unit tests, you've documented it so other people know how to run it or fix it if something goes wrong and you're not around. But I think you should stop for a moment and reconsider just jumping into production. You should definitely have a pre-production environment to test your project in before actually putting it in front of customers or in a place where it can affect customers. And you have a couple of options to do this. You can create a full parallel environment that is almost exactly the same as your production environment and test things out there. That's usually the ideal, but we may not have access to the resources to do that. So you can usually set up, smaller environments in a VM and test it there. But I urge you to think about actually running everything in as full an environment as you can achieve before trying to affect customers with your code. Like for OpenStack, there is a DevStack project which will allow you to set up a complete OpenStack install on a VM so you can run your service against real OpenStack code, which is what I use for Arsenal. Another great tool to have with your project is a dry run option. You may have it in production or you need to get it into production, but you want to do so without actually affecting production even though it's there. So a dry run option with your project should run the service as much as possible, but without making any changes that would have side effects outside of itself. This way you can go to production without going hurting production or causing any problems, and you can see if it actually seems to run without actually hurting anything. Another great thing to have in your service is plenty of logging. I have a question for the audience. How do I know if I have enough logging? Anyone want to take a stab at that? You don't? You never do. Well, I mean, my answer is if you can't figure out what's happening, then you need more logging. A lot of times, you'll figure out that something's going slightly wrong with your project, and you won't have enough insight to see what's going on. But you should try and log as much as you possibly can. Log everything that your project is doing. Log errors as they happen. Hopefully you can handle some of the exceptions your project may throw. And I think a good thing to keep in mind is if you can reconstruct what was happening in the log, then you've got a pretty decent log going. And also, before you deploy to production, a great thing to have is the ability to deploy in one step. These are a couple of tools that I use to provide that ability. Are any of you familiar with Ansible? A few people in the back. I think they're mainly rackers. Ansible does a great job of automating steps that require reaching out to another computer, like reaching out and installing the latest version of your service, redeploying configuration files, restarting your service. It's definitely, when I first had to write my deployment script, I really didn't want to do it, but here I am a few months later, and I'm really happy I did. For instance, just this last week, I discovered something going wrong in Arsenal, and I was able to write the fix in a couple hours and then deploy it to pre-production a few minutes later, make sure everything was going well, and then a few minutes after that, I was able to go to production with code that I had written that day, and be really confident that it would work. And Jenkins can provide that button. It provides some nice build environments for your project.
What about the frequency of deploys? Do you believe daily deploys that you should deploy every day?
I mean, if you're writing code every day, you should probably try and deploy it as often as you can. The rationale being that you've written your unit tests, so you have confidence that your code, the new code, is not going to break old code, and you've written unit tests along with the new code, so you have confidence that the new code works mostly as you expect. And if your test, as long as you test in some sort of pre-production environment before you go to production, then you can suss out anything before it will affect customers.
Yeah, and I was thinking about more along the lines of consolidating branches and testing and deploying every day. Because I know a lot of times they use a unit test on a branch and everything's cool.
Yeah.
And they merge it back into the main code.
Mm-hmm.
Boom, now we got a problem.
Well, I mean, the answer to that is if any of the tests are broken, don't deploy. Like you don't want to introduce any errors into production if you can avoid it at all costs. I think my team wants to move toward a continuous deployment situation where we're not even involved in pressing the button to deploy. We want to get to a point where it's always deploying every day, maybe even every few hours. But we can do that because we have the confidence in our code from doing so many different things to test it before it actually gets there.
Yeah, I know some shops take all the branches and merge
Mm-hmm.
and deploy at lunchtime, and then whoever broke the code gets to fix it after lunch.
Sure, right. I don't know. I still got to do more thinking in that area. So here's a quote I'm sure most of us are familiar with. It's one that I found to be true. So you're going to production, and it's scary as hell. I mean, something might go wrong. You might hurt a customer's experience at some point. But again, I want to reiterate that it's probably not that bad if you wrote good tests, did pre-production validation, you added logging where appropriate, and you can deploy your project quickly. All these things lead to a situation where if there are any problems in production, you can quickly and easily mitigate them or fix them. And in the case of Arsenal, everything went better than expected. I don't think there have been any customer-affecting bugs with Arsenal, which has been a pretty great situation to be in. And I think that I got there by using all these different tools that I've presented throughout this talk. And the thing you need to do the most also is iterate on your project. There are bugs. Some things will not be as great as they could be. But because you have all the tools, the continuous integration, the continuous deployment, it's really easy you've made your life easy, and it's very easy to iterate. So to sum up, we, and I mean, by we I mean you, can do it too. Arsenal uses all the tools that I pointed out. They're freely available to you and can make your project make it to production as well. The road is long and scary, but with a little elbow grease, you can get there as well, and I think have really good outcomes. I hope they work well for you too. Any questions?
Do you have any tools you would recommend for loading?
For loading?
Yeah.
What do you mean?
A lot of times customers will load it in a different manner from the development capability.
Right. I haven't really run into that situation with Arsenal yet, so I can't really comment personally. I'm sure there are good load testing tools for Python. Anyone have any suggestions? No. Sorry? You said machine gun? Bees with machine guns? Is that a real project name? Okay. Maybe you should try looking up that. Any other questions about writing a project for production? Yes?
Why do you use Travis CI and Jenkins CI both?
I think that's an artifact of the team using Jenkins and like the broader Rackspace culture. They had Jenkins CI already set up, and then for some reason I decided to go with Travis CI for continuous testing integration, because it integrates really well with GitHub for one. Anything else? Hopefully we all learned something here. Hopefully you weren't all aware of these tools beforehand and I wasted my time and yours. Well, if there are no more questions, I just want to say thank you.